Okay, hello everyone, welcome to the Kuma community call. So please add your name to the attendee list and feel free to submit any agenda topics item you would like to discuss today. I think everyone has a link to the doc. And I think we can start. So we didn't release anything since the last Kuma community call. That's why no updates for releases, but we implemented some cool features, and I think Jacob can give more info on the first one, graceful shutdown.
Yeah, I can even do a quick demo on this one.
Oh, that would be awesome.
Yeah, so with the next release, we will be fixing the graceful shutdown of Kuma DP. So right now there was an option to set a graceful, to set a draining time in the Envoy configuration, like it's globally for every Envoy, right? But the problem is that we were not really respecting this in a proper way. So so just to show you, I have a Kubernetes cluster on GCP with our counter demo app. So so that's the demo app with Redis. And let me port forward the control plane and demo app. So that's the demo app on the left. If I do auto increment, I have one instance of Redis, right? So this is it. And now if I scale this up to 2 instances, maybe let's also see the list of data plane proxies in the CP. Just demo app and Redis, that's it. I'm running the version from master, right? So let me scale this and let's watch the pods. So there is a second Redis pod, right? Which is offline. Going back to this because that's the most important one. You can see that now we are kind of alternating between 2 instances of Redis. You can see that the second instance is this one because the counter is really low, right? So that was not a problem so far because we were taking into account this endpoint for clients whenever the pod was ready, right? The problem was if we scaled this down from 2 instances to 1 instance. So previously we were kind of relying on the retry policy, on the default retry policy, which was not ideal, right? So let's see what happens now. If I scale down to 1 replica, as you can see, almost immediately we can no longer see that other instance. If we go to list of data planes, we see that this one is offline, right? And it says that part is not ready because it's marked as unhealthy because the Envoy health check is not passing anymore. So to give you an overview what is happening with this change, the flow when the pod is going down on Kubernetes is that Kubernetes first marks the pod as terminating, right, via the annotation on pod. So whenever we see this, we immediately mark the data plane object, which is like an equivalent of pod as non-healthy, which triggers all the configuration changes for the client to exclude this from all the potential endpoints, right? Then Kubernetes concurrently for every container, it executes any pre-stop hook. If there is a pre-stop hook, I will get to this in a second. Then it sends a seek term signal to every container, right? And then it waits until the container is no longer running. If the container is running after the graceful time, which is set on the pod, right? Then kubelet just sends seek kill and gets rid of the container, right? Then the pod is removed from the system and that's it. So the problem with this one, so from the Kuma DP side, what we've done is we've implemented a logic whenever we receive the seek term signal, so this one, instead of just exiting the Kuma DP container, we mark this as unhealthy, but we are still running, which means that we can still accept the connections. Envoy will send back the connection close header if this is HTTP, which means that the client can just reconnect to another instance. But what is also important is how do we handle the application in this case, right? Because if kubelet concurrently executes a seek term on every container, and if application goes down immediately, then, well, Envoy is alive, but application is not, so there is a problem, right? So there are two options. One option is to just teach the application, so implement the graceful shutdown in the application itself. So application receives a seek term, waits for a couple of seconds, and that's it. But with Kubernetes, there is a second option, which is a pre-stop hook. So this is what I implemented in Redis, because Redis just stops after receiving the first seek term, and obviously it's hard to modify Redis to wait, right? Maybe there is such option, but the alternative is to, let's see the pod. Kuma demo, Redis, YAML, and the Redis container is here. And as you can see, there is a post-start operation after the container is started, but I added the pre-stop operation, which means that it's executed before the seek term, right? So application will be also sleeping for 30 seconds. This should be in line with the drain time that is set on Envoy. So in this case, we have a time to exclude this endpoint from all the clients. So this is how you do a graceful shutdown. I was considering adding this pre-stop hook by default to every container if we are injecting Kuma sidecar, right? Which would be really cool, but I feel like that's probably dangerous because, well, there is no guarantee that there is a bin sleep in the container and so on. Yeah, so that's Kubernetes. I can also show you quickly how does it work with Universal. So let me run just in-memory control plane. Okay, you see a beautiful animation. Script setup. Okay, so I have no data plane proxies, right? Let me start my data plane proxy. I have like a very simple script that generates data plane token and starts data plane with like an inbound defined. Okay, so if I start this, I now can see a data plane proxy here, and it's not yet healthy because the status is flashed every 10 seconds or so. Okay, and now it's online. So now I'm sending a seek term by pressing the Control C. And in the logs, I can see that connections are being drained. And here I can see that the data plane is offline, which means that it won't be included for the client, right? Of course, on Universal, you need to take care of the graceful shutdown of your application yourself. There is probably no like hook on Kubernetes. Maybe there is, but it depends on your kind of environment on which you are running this. So, and there you go, it stopped, and the data plane. Okay, that's interesting. Should be gone. But for some reason it's not. But it's still offline, so it's not the end of the world. Yeah, okay, that's it. Any questions about this one?
So in Kubernetes, it works without retries in your demo.
Yeah, as you could see with the counter demo, I scaled down, right? And you could not see any like connection problem or like, you know, waiting for connection. You could see before. So yeah, we even have end-to-end tests that I just remove the retry first, and then I send requests in the background and scale up and down and see that we don't drop any requests.
I had a really quick question about the last bit where the data plane didn't disappear and just showed offline, because I've seen that recently as well. Do we just keep them for a certain amount of time? Because I mean, it is useful to see that there was one and it's now offline. I just couldn't find where that was implemented.
Yeah, so we removed this after some time. Let me see. So in docs and data plane on universal, there is a life cycle section. And this one, you're probably interested in this one. So there is a configuration that if the data plane is still there offline after 72 hours, we just remove this.
Okay, perfect.
Yeah, though if the data plane proxy shuts down gracefully, it should remove the data plane.
Yeah, it should.
Automatically.
So yeah, it should. So that's kind of interesting what happened there. I need to look into this.
So you hit Control C to send sig term. So I thought that sent sig int. Did you like change the?
Oh no, sorry, it's probably sig int. Well, either way, if like we listen for different signals, so it can be either one of them.
Same way int or term. That makes sense.
Mm-hmm.
Okay. Thank you, Jacob. So I think we can move forward and chat about sidecar customization. That's big PR, big proposal with a lot of discussions. Not big proposal, but a lot of discussions here. So yeah, Paul, please update us. Yeah. Do you want to click that, or do you want me to share my screen? Yeah, I can click on it. Okay. Yeah, it's not like Ilya said, not a long proposal, but generated a lot of discussion. So yeah, if you just want to click on the files, and you can just view and then click on those three dots all the way to the right. And I'm pointing with my finger. All the way to the right next to viewed. Yes, and then you can do view file. It'll actually render the markdown. So this is what we settled on. Started implementation on it yesterday. It should get into this release. If you scroll down a little bit, you can. It probably makes the most sense to talk about the example. So, yes, for anyone who's not familiar with discussions we've had and what this is all about, people want to be able to modify the init container and the sidecar container that we inject into a pod. So what we settled on was a JSON patch format of doing this. So we have a CRD, which will be a new CRD called container patch. That CRD will be matched to workloads via an annotation on the workload. So you will, either on your deployment, on your pod, or whatever, you'll say annotation. I'm sorry, yeah, and you'll reference the name of this container patch. And then for the sidecar container and then the init container, there's as you can see here, there is a YAML version of JSON patch. So JSON patch actually has an RFC. You can go to the RFC and see exactly how it works. It's actually really simple. You have a path to what you want to change, and then you have an operation. So you can add, remove, modify, copy. I think add is what we've gotten the most requests for, right? People want, in fact, what you see right here is what we've seen the most of, is people want to be able to modify the security context. So this should be a pretty simple way for them to modify the security context. You just say you want the security context, you want this value in the security context, which makes a path, and then you can say what you want to do with it. What else is there to say about this? Oh yeah, so some of the discussion that we had was like, what do you do if there are, like, in the past we had other ways of matching this, and we were thinking about like, what do you do if there's like conflicts or multiple matches? So what we actually settled on, and you can see down here is like an example of what it looks like on a deployment. We have this annotation,
and you just have the patches you want to apply in order. So I think this is pretty easy to like reason about. You just say, well, I know what my init container looks like. I know what like this patch and then this patch. I think anyone who's used, Git or diff or anything, they know that. I think it's a pretty common way to think about applying patches, right? And then we also have we'll have a default reference in the Kuma config to a CRD, which will allow you to do it to, I guess, everything. And I guess one other thing is yeah, I guess that's basically it. We're nothing special for multi-zone. We're not going to validate that you have like a semantically, or we're not going to validate that your configuration is sane, but we should be able to validate that you have like you've generated a legit container. I think that makes sense. That's about it. So yeah, it's not a huge proposal. It did generate a lot of discussion, but that's where we settled. Any questions, comments, or snide remarks?
Are we able to return error when in the moment when you create deployment?
Yeah, so that is
fair.
actually that was part of the discussion as well. Yeah, so what we settled on was that we want to log the error. So like let's say something goes wrong, right? Like you don't have a patch here. I'm sorry, like the patch doesn't exist, right? And so what we're going to do is we're going to log the error, and we're actually going to abort the inject. And the reasoning is that you could be like applying security features on top of your container, and if we can't do that, it seems foolish to fail open, right? Because you might fail open with like incorporating something into the mesh that someone was not ready to have incorporated without the security features. So you get a log error, and then you get it does not have the sidecar init container injected. Does that answer your question? Is that?
Yes.
Cool.
This is awesome. This is going to solve a lot of issues that come up quite a lot in the issue tracker and customers and users and stuff. So cool. Good job,
Thanks,
Paul.
John. And thanks for all the feedback, John. I really appreciate it.
Any other question for this proposal?
I feel like anyone who's actually followed along, this has been like done to the death. So there's probably not too many questions.
Yeah, okay. Thank you, Paul. Okay, next, I won't take much time. I just wanted to update everyone. We had proposal for new policy matching, how we want to change this. And essentially, we decided to slightly change what we thought. So this is first version of the proposal. You can check if you're still not familiar, but maybe it's already outdated. But still, we decided that we need to support routes better, especially because we have like experimental mesh gateway and it has mesh gateway routes. So we want to treat routes as a first-class citizens in our policy. That's why we decided to think about policy matching one more time. And essentially I here have a small draft, and it was mostly inspired by new gateway API in Kubernetes that has like policy attachment concept, and it has target reference. And we want to utilize this thing. So here's an example. If you have traffic permission, you can essentially put target reference for the mesh. It will mean that this policy will be applied to every proxy in the mesh. And inside configuration, we now want to have like this idea of direction, because some policies, they have from. So, I mean, if you configure them on the inbound, it means that something from, for example, traffic permission, and you deny or allow traffic from all other proxies in the mesh. Some other policies, like circuit breaker, for example, they will have to instead of from. Yeah, so for traffic permission, you can put another traffic permission for service backend. And essentially, we will merge this all together. This concept is similar with what we already had. So we will merge this into a list of rules where this rule comes from mesh policy. This comes from this policy, and then we will generate configuration based on these rules. And available target refs are mesh. So essentially, you can attach your policy to mesh, to service, to proxy group, to just proxy, one proxy, to mesh gateway route, and to HTTP route. So these are main reasons why we rethinking all of that. So can't share full proposal yet, but I think it will be during this week. So yeah, this is it.
Yeah, one point that is an improvement on this side is like the target ref that is like on the top of the policy always identifies it's a selector of a number of data plane proxies that you're actually modifying the configuration of. Whereas before, the selectors would sometimes like select things, but actually it's applied on policies, it's on data planes that are reaching out to you, right? Which was like not very intuitive in like figuring out what is being modified by your policy, right? Whereas now it's very explicit, it's whatever is in this stop bit.
Yeah, we're trying to be more explicit here. So any other question for this small draft? Okay, let's move forward. And I think, John, about good first issues, you wanted to bring up this.
These two are mine, but I'm going to abdicate my spot and let Jimmy talk about his tunnel use case if he wants.
Oh, yeah, sure. Do you want to share, Jimmy?
I think you have a sound problem, Jimmy.
Yeah, I don't hear.
Yeah, you're unmuted, but we can't hear you.
Is that any better?
Yes.
Right, this is the wonder of Zoom on Linux, right? It just never, it keeps flipping my mic. Anyway, first world problems, right? Yeah, so hi, I'm from D2IQ. We build up like multi-cluster stuff, and one of the things I'm exploring is how we build this around a mesh. We actually have kind of got a home-built kind of networking topology at the moment, and want to move to something a bit more all-purpose, right? Something that we can adopt, configure. One of our use cases, so I've got this all set up actually using Kuma already in nice, simple networking topologies where there's connectivity between egress and ingress everywhere. And yet, a number of our use cases, a number of our customers have places where they can't connect from between clusters. Only a one-way connection. It can go from cluster A to cluster B, but not back the other way, right? Initiating connections. So we end up setting up tunnels, reverse tunnels. We use something called Chisel actually to do like a SOX5 proxy actually in the middle to reverse tunnel and TCP tunnel through that. And I was thinking, like, can we do this with service mesh the way it is? And my kind of do you need any more info on that kind of use case? It's effectively to allow traffic from egress in cluster A to ingress in cluster B, when the only way for connectivity to be initiated is from cluster B to cluster A, right? So that's the problem. Any thoughts, or do you want to carry on?
Yeah, I think it's a great use case, like, and it's for sure like our thing of needing two-way connection is kind of a shortcoming of Kuma, right?
As well as the question is, what type of the tunnel should it be? Should it be only the TCP one? Should it be some higher level in the stack, or as well UDP? What is the requirement there?
So in our use case, it's literally just TCP, right? So that would satisfy. So that what I was kind of thinking was how you could initiate like a reverse tunnel by connecting something in cluster B to effectively the egress in cluster A, maybe or some other service in cluster A, and changing the ingress address for cluster B in cluster A, right, or zone, whatever we call it, zone A, zone B. So effectively, it would actually route to this tunnel endpoint that would then route it through, and then you'd be effectively in the ingress in zone B, right? So I have no experience with Envoy. I have no thoughts about how we do this. So yeah, any idea? There's anything that we could play with? I could hack on any pointers.
Actually, I think that the only thing is because we probably have to use Envoy. So if Envoy allows some kind of tunneling by default, so the only point I would start with is to see if there is any existing tunneling, I don't know, protocols or tunneling solutions working with Envoy at this point, because I have not heard about it yet. But
so we can tunnel TCP through like HTTP2, but it's the reverse tunnel that's the problem. Like tunneling, I think is fine. It's the reverse tunnel that becomes a problem.
Yeah, you're right.
So how does it work with many clusters? So the use case that you are describing is with 2 clusters, right? What happens with like more of them if there are kind of one-way connections?
Yeah, so for our particular use case, we have a centralized cluster, and that is kind of the management cluster for a federation of clusters. So it's kind of in our particular use case, it is actually only all these clusters connecting to one cluster, right? You're right when you get into more of the kind of, and that's kind of, you could work with that hub spoke model in that scenario. You're right, if you wanted to do this with more, then there would need to be connections to all the ones that you can't connect to. But I wouldn't expect that to be I'd expect that to be some. Maybe we could introduce another kind of routing cluster in the middle. So another proxy layer in there. So if you were going into a particular different data center or something, or subnet where you don't have routing, you could route it through a particular single cluster in there. So it's like a multi-zone ingress in a particular locality or something like that. I don't know.
Unfortunately, I need to drop because I have another thing. So sorry, but that's an interesting use case.
You ask a good question and then you drop. That's not right.
Sorry about that. Yeah,
I mean, it's almost like MPLS that you're describing or something, right? Not MPLS, but like something that takes something from one mesh to another on using some kind of label rather than like IP routing.
Yeah. Maybe.
Right. Like, do you want to like maybe the next step on that is like if you could like start an issue, right, about what this would look like, what are the requirements and stuff like that, and then maybe we can try like all together like hashing out like IDs. I think in itself like it's a feature that makes a lot of sense, right? It's like, and that's one of the places where Kuma is supposed to be like good at, right? So yeah, I think we should discuss it and see where we go, and then like if you want to like try to contribute it, if we manage to find a design that works well, like, let's go, right?
Yeah, I'll be really happy, like with help to contribute something here. Be absolutely with support, definitely. Yeah, nice. Okay, I'll open an issue and detail that. That's because I like with what we're kind of working on. I think this could be a pretty awesome generic multi-cluster management kind of scenario. Like this would actually change the multi-cluster management plane for Kubernetes, right? Which is an unsolved problem at the moment. And I think mesh is the answer. So I think this could be a really big thing, to be honest. So yeah.
Nice. Yeah. Cool. Yeah, I guess we had like a similar thing as that with like multi-zone, right? As in global, and we started as to reach out to global. It was like a two-way connection. And it was like the zone would reach out to global and global would reach out to the zone. And that was like a mess for multiple reasons, right? And I guess it's very similar for you, right? It's exactly the same case.
Yeah, absolutely. Yeah.
Okay. Well,
Yeah, unfortunately, we're 3 minutes late. I think we should wrap this up. And yeah.
Yeah, sorry. Thank you for your time on that. That was great. Thank you.
Yeah, thank you. And yeah, see you in a month or other. So thank you, everyone.